Hey, hello. Uh, Welcome to the first in a series of online workshops that will help us better understand what FLR is. Yeah, do we hear each other? Cool, great. So we're here to learn better what FLR is, how we can develop on FLR, and how FLR-specific technologies can help us here. I'm Filip Koprivec, head of DevRel here at FLR, and today we'll dive into the really basic on what FLR is and what's happening. We have some quite ambitious plans for the series, from learning about the oracles, how to deploy smart contracts, to programming directly with the native oracles that are available on FLR and directly enshrined in the blockchain itself. I'll invite multiple people to present here, from engineers to people that work with me, to community partners. So be prepared to hear about the protocols directly from the people that made them possible and from the people that are using them right now. And don't forget, subscribe to our newsletter and stay tuned for the information on the next one, but it will probably happen sometimes mid-November. So before we jump in, if you're on YouTube, there's a chat window, and please, if you have any questions, leave them there. If they come to mind during the presentations, at the end, we'll have a short Q&A session, and we'll collect some questions. We'll try to answer them, but otherwise, don't worry. I'll have a QR code for our Discord server. Join it there and ask questions there right away. So we have a dedicated Discord support group, and we also have regular office hours. So anytime you have any questions about FLR, developing on FLR, doing something there, just ask it there and you'll get somebody to help you. And maybe for some additional alpha, if you stay until the end of the presentation and listen carefully, there might be some surprise for you, but I can't say anything else. So let's jump right in. So that's the logistics, and now see what's happening. So FLR is a blockchain for data, but to fully understand what blockchain for data really means, we have to go through each of the words and see what it means. So let's briefly check what being blockchain firstly means. So blockchain, as you can see in this picture, is just a chain of blocks, nothing that specific. So it's a ledger. It's a ledger of some content. And what is on that ledger, what the content is the thing that matters. So the first really successful blockchain, Bitcoin, the ledger of Bitcoin contained only the information about transactions and balances, and you could then extract the information about who transacted to whom and get some additional data. But from that time, we've came a long way, and the ledger, the one that you're probably used to, so Ethereum 1 or some layer 2s or so on, can contain much more information, not just balances, but most importantly, the results of computations. And this can be thought of as a memory. And the second part, this ledger has to be distributed. The core purpose of blockchain is this security property. So you have this security, you have anonymity, and the ability to remove the censorship. The thing is, there is no central party that holds full control over the ledger, and there is no central party that can modify the ledger at whim. So what that means? That means that the whole thing is controlled only by mathematics, by the algorithms, and that you're sure that something is either gonna happen or not. You don't have to be careful about stuff. Importantly, this means that by design, the design of the blockchains ensures that each of the blocks, every state of the ledger and anything that happens can be independently verified by anyone that follows the same algorithm. And all the state transitions, all the transactions, all the memory transitions, all the computations can be verified. This is the core aspect of this security. So somebody can propose a block, but there is no single party that can force a block. Anyone can verify this and make sure that the block is correct, and they agree on it. And this is amazing, actually, because that means that you only need to understand and follow the rules on how transactions and how things on blockchain operate, and that's it. You now have the full security. You now know how to interact with people on the other side of the network, on the other side of the world, and you don't ever need to trust somebody to not do some funny business. And doing this pretty much opens you a world of possibilities that was previously unavailable. And those applications that function on blockchain, you probably know a lot about them, usually need something more. If you add anything to a blockchain, you need to be sure that you haven't tricked the blockchain to doing something nefarious, and you haven't imposed some additional security restrictions. And this is where Flare shines. So we take a blockchain, we make sure that this core ethos of blockchain is still preserved. So you have these algorithmic things, you know what's happening, you know when the transaction is correct. But we also add additional external data that you can use on blockchain without compromising the core security aspect of the blockchain. So the core reason why you want your tab or your user even to be on blockchain. So you want this security aspect, you want to be sure that everything works. And when you have additional data on top of it, you don't want it to compromise the initial thing, the why you want the blockchain at all. So Flare is a blockchain. It means that it obeys the same general set of rules, and most specifically, it's a layer one EVM compatible blockchain. So what does being layer one means? Being layer one means that it is a totally independent of any other blockchains. So we're not a roll up, we don't do any checkpoints on another blockchain. We have our own set of validators that are building and verifying blocks according to the algorithm. We don't deposit those blocks to any other blockchain, and we don't depend on any other network. This is important. So to conduct a transaction on Flare, you need to just interact with the Flare blockchain, but you need to pay the gas fees, as is usual with the blockchain. And to do this, you have to use the native token called FLR. And this native token, as is the common thing, is also used to reward the validators, to reward the delegators, and everybody else that participates in the things that build the blockchain. So we use a proof of stake. That means that the validators stake tokens to get the ability to propose new blocks. And this allows us to run the chain very efficiently. So anyone can become a validator by having a sufficient amount of stake. But this allows us to, compared to a proof of work, to run a blockchain efficiently, where a new block is mined approximately every 1 or 2 seconds, making the transactions go quick and also being efficient energy-wise, not consuming too much electricity, and so on. And we also made sure that we are EVM compatible. We'll learn about this a bit later, but that means that we are compatible with most of the existing wallets you know. So you can easily use Flare on existing wallets, MetaMask, Rabbit Wallet, or even hardware wallets, such as Ledger, Trezor, and so on, by just adding a new network. There is no additional configuration. The apps are available. So it's easy to add Flare as a new ecosystem. It's easy to interact with it. But what we add additionally on top of the blockchain is these additional data oracles that give you much more power when dealing both with dApps or being a developer and doing something more. So just to explain some phrases you might be hearing about Flare. So Flare is an ecosystem of blockchains, actually. So we have the Flare mainnet I talked about before, and you also have a test net called Coston2 with its own token that has no real monetary value. The main purpose of the testnet is that we always make sure that the core protocols available on Flare are closely mirrored on Coston2. Why is that useful? Where it gives the developers and the users the ability to play in a free sandbox, to test the applications, to interact with them before the applications go live. And this makes everyone's life much, much easier because it allows for faster development cycles, faster deployment cycles, and you can easily explore what's happening with the protocols. So when we offer a new price feed, it's very easy to see how it behaves. It's very easy to see how to query it, and it's very easy to create a new application that interacts with it. And once you're sure that this works, you post it on the mainnet where the real activity happens. And there's also the Songbird. Songbird is a canary network. And we also make sure that Canary Network has similar products as Flare, similar core products. So FTSO, FDC, the FSP, they all also exist on Songbird. But the main purpose it is that they're usually released a bit faster, so you can still experiment with them a bit before they're released on the mainnet. But you can do this on a network that has value, and Songbird has value and already has a rich ecosystem of applications, of DeFi products, and so on. So you know that you can test application in a real network, in a real network with a value, but just with maybe a smaller community, a differently paced network, or a differently paced ecosystem. But beware, they're still two independent chains. So you have different ecosystem, different bridges, different coins. Okay, and now the EVM compatible word. So what does EVM compatible means? So it means that the validator nodes run the EVM, so the Ethereum virtual machine. And what does it do? Well, Bitcoin allows you to send money to each other. Bitcoin also has some additional scripts that you can run. But Ethereum virtual machine, apart from just sending transaction to each other, you can send a transaction that has additional information about what needs to be executed. And this is encoded in so-called EVM opcodes. This is the language that nodes also execute when you do something. The language, the EVM opcodes, the Ethereum virtual machine opcodes, is the same as the one of the most commonly used smart contracts chains that you know. So Ethereum, various layer 2s, various copies, various different applications, and so on. But thankfully, you will probably never write directly in the assembly language. You can, but if you at least have some sense of what your time is worth or why you need it, you'll probably firstly use the Solidity. Solidity is a higher level language that then compiles to EVM, and it's the one that's most commonly used to build applications on EVM compatible chains. And one of the benefits of being EVM compatible, specifically one of the benefits of having all this ingrained directly in the validators, is the ability to have these standards and the most common execution architecture and reuse the tooling and reuse everything that is already available on the internet for the developers and both for the network. So we can reuse the Solidity, we can reuse the Viper, but also the tooling. So if you want to develop on Flare, you can easily use Hardhat, you can use Foundry, you can reuse existing Open Zeppelin libraries. If you know that if you use an existing Open Zeppelin library, you can rely on their audits and so on. So you don't have to build things from scratch. You can build on top of the things. You can stand on the shoulders of giant and build something more built with the data. What this does? Well, this eases the development experience, but also boosts the confidence about the applications, as you don't have to invent new things, you don't have to invent new toolings, you don't have to invent new transparency procedures. So we have Block Scout, where you can easily explore the transactions happening on chain without having to build your own one. And you can reuse the tooling and make users transition to a new chain much, much nicer. You can reuse subgraphs, you can reuse Gold Sky, and so on. Even the wallets I've previously talked about, they all rely on this EVM compatibility. In fact, practically all the enshrined protocols we're going to talk about today are implemented using Solidity and work directly on the EVM. So you can verify them yourself. You can go to the Explorer, all the contracts are verified, and you can make sure that the contracts really do what I'm going to talk to you about. Okay, so being EVM compatible means having smart contracts. But what this really means is that apart from, as said before, just sending the funds, you can do some computations. You can compute on top of the chain, and since this is Turing complete, apart from the gas costs, and the gas limits, you can do pretty much anything you want. There is no limits. If you can think of it, you can build it. So, for example, natively on Flare, you can have ERC20 tokens, NFT tokens, and much more. So you can have AMMs, and we do have a bunch of AMMs, but you also have some additional rich interactions between the contracts. You can also do some additional computing, and all this without having to change neither your wallet, neither your development environment, just changing your RPC. And you can do something more. You can do some additional stuff because we have this new additional data. Well, data in depth. Do you really need? Well, actually, you do. So we have this additional data, and if you think about blockchain, if you think about any new thing that emerges, the first thing that it starts with is in isolation. But nothing can work in isolation. If you do some computing in isolation just on a blockchain, there's only so far you can get. And there's only so much thing the users can do with your programs, the users can do with your product. But if you get additional information, if you get additional data, so for example, if you can get information about Bitcoin payments on a chain that can sum them up, on a chain that can group them, on a chain that can see that you're paying a specific address, that you're paying a specific account, you can do much, much more. If you have information about the bank payment and information about the Bitcoin payment, you can create a cross-chain swap. If you have a weather data and event attendance data, you can compare them. You can use this real-world data and gather the users that want to use the real-world data, but you can also interact with the real world because you can see what's happening and you can observe the effects. So what does that mean? That means that any users that wants to use blockchain with something new, not just playing around in an isolated, clean this in a, you're opening. Okay, so we see that data is useful. We know why we need the data, but the question is, how do we get this data? How do we know what's happening to the data, and how do the application access it? Well, the usual thing we use in blockchain is called oracles. So oracles give you access to the data in some way. How exactly? Well, that's where the word comes from, in some magical way. So we'll dive deep into that topics in our next session. So what are oracles? How to properly build them, what they can do, what they can't do, and specifically what are the problems that arise from it. But let's just take a look at what specifically are the things that can be problematic. So let's say you want to get some data from the outside world. Execute a search query. You need to be certain that if the results of this search query change, you'll still get the correct thing out. If you want to query an API, you need to be certain that everybody is going to see the same thing. And what if the thing changes at a later point? And in a blockchain world, you have to be sure that you can always verify data after the fact. You need to verify blocks after the fact. So you need to make sure that if you're interacting with an external world, you bake this in such a way that this doesn't change through time. And one of the most important oracles is the random oracle. And you want to source randomness from somewhere. So blockchain is a very good example of how a trustless environment is a nice way to create some sort of prediction market or a gambling. And you need some random for this. But if everybody can verify the random and somebody can know it in advance, well, you're up for a problem because it doesn't make sense to do it. And specifically, the pricing source. If you want to have a price on chain, well, you can do it. But what happens if somebody that's providing you the price can manipulate it? Well, that's fine. At least at some point, you might need to trust them. But the problem is that as soon as you're in a decentralized world and anyone can be providing you this price, or you don't know who exactly is providing you this price, you might be on the hook that the person providing you the price or the entity providing you the price is opening a short position somewhere and might profit from this price being problematic. So those are all the things that come with the word oracle. So all the things that you need to be careful about when considering getting the external data, and all the things that need to be thought of when designing a system that gathers data in a secure manner. And well, how do we do this? Well, on FLR, we have these enshrined oracles. Why enshrined? Where we push the oracles directly in the protocol so that we make sure that the data cannot be tampered with, the data is secure, and the data is always available. And to do this, we use a few protocols that have names. One of the currently the top level protocol is so-called FLR system protocol, the FSP, and the FSP makes sure that all the sub protocols function properly. This is going to be explained quite in detail by one of the engineers designing and building it. But for now, think of the FSP as a top-level protocol that makes sure that everything works as it should, and make sure that the rewarding works as it should, because the rewarding is the core part of making sure that the incentives aligned. And the next one is the FTSO. FTSO stands for Flare Time Series Oracle. Flare Time Series Oracle provides access to probabilistic data sources. Well, this is a fancy word, but think of it something like this. If you can measure something, and if the number is still okay, even if it is just a bit off, FTSO is good for it. So if you can measure temperature and 55 degrees or 55.1 degrees is still sufficiently okay, then FTSO is good for it. And FTSO specifically is good for pricing data. So if you know that Bitcoin is $65,000 or $65,000 plus one, you're still in the correct ballpark. And the second of these sub-protocols that nicely plug into the FSP is the Flare Data Connector called FDC. Flare Data Connector works with deterministic data. Again, a fancy word, but what FDC does, it allows you to get answers to yes, no questions if they're posed with sufficient degree of detail. So what it allows you to say, okay, did this specific Bitcoin transaction happen? And if it did, can you provide me some additional details? And in that case, you don't want any wiggle room. You need a yes or no answer, and you need exactly who the sending address was and who the receiving address was. You don't need them. You can't live with, well, receiving address looks somewhat like it. You need a proper answer. But on top of this, you can build a lot of new things. So you have FTSO for probabilistic data, not only prices, pretty much any data feed that moves and can be correctly approximated. And you have FDC that gives you yes, no answers. And how do we make sure that this works? And how do we make sure always on chain and most importantly, always secure? Well, this doesn't magically appear. So we have to put quite a lot of work into it to make sure that this works. Well, how do we do? Well, the backbone of this are FLR data providers. So data providers are entities that are bundled together with a validator. So the validator, this is the thing you've probably heard on other blockchain, is the entity that is proposing, building, and validating blocks. And on FLR, this works the same, but we also include another responsibility, which is providing secure data on chain. And we bundle this with validator and require a stake on top of it. That means that, again, as validators on any other chain, the data providers are also permissionless. Anyone can be data provider, provided that they get sufficient delegations, and we call this vote power. Anybody can be a data provider and a validator, and have a say, and must have a say, in what the correct data both in FDC and FTSO is. And this sufficient delegation, sufficient vote power can be acquired by other people, getting sufficient FLR, or staking it. And again, the important thing to keep in mind is that all these things are necessary to make sure that your data at the end is secure. So security, you can think of security as a chain of choices. You can make your DApp as secure as possible. You can audit it. You can make sure that everything works. But if you're sourcing data from somebody that has an incentive to provide you wrong data, well, the security of the whole chain collapses just because you messed up with single data sourcing. So what we do on FLR is we make sure that the whole chain, from sourcing the data at the source to computation, to getting the data to contracts and smart contract computation, is always secure and secured by the same thing. In our case, the stake of the whole network. Okay, so how exactly do we keep this secure? So how do we make this blockchain system secure? Well, we use stake. So as said before, FLR is the proof of stake chain. So each validator, each entity, each data provider in the system has some incentives. And to make sure that the incentives are aligned, the validators that build block and provide data have to put up some stake in the system to make sure that they're providing good data. Providing bad data would hurt them. So again, the court part is properly setting this up. So being a data provider is permissionless. FLR, the organization, we don't control who the data provider is. Anyone could become data provider, and we're encouraging a lot of people and a lot of professional organizations to be data providers because getting good data is important. And anyone can do it. And the inflation system is designed in such a way that providing good data gives you more rewards at the end, and this in turn gets more delegations, getting you even more rewards. But we also always make sure that we properly decentralize this, so we don't have big whale providers, but we have a lot of small providers. And currently on FLR, we have around 100 data providers that are constantly providing data sources, and we always monitor them to make sure that everything works. And how do you do this? Well, the easiest way to do it is to have up and running monitoring, but also sometimes you have to check it yourself. So we have developed a specific FLR system explorer for both FLR, Songbird, and all the test network to see how everything is progressing, that allows you to constantly observe and see how different data providers are performing, what they're doing, and what's happening on different protocols. So what you can do, you can always go directly to FLR Systems Explorer and see who specifically data providers are, what they're doing, and what's happening with them. So as you can see, we have quite a lot of data providers. You can see their fee. You can see what they're doing. And there's quite a lot of professional ones. We are constantly looking for new data providers. We're encouraging big organizations to join, because what we want to do, we want to create a huge ecosystem where data providers not really compete, but where they complement each other, making sure that they provide good data. Okay. So this is how you participate in the system. So this is how you add data to the system and make sure that everything works. But the question that should pop out is, well, how can I participate in the system if I'm not providing the data? If I'm not big enough to be a data provider? Where the first thing, if you have some FLR tokens, the easiest thing for you to do is to wrap them and delegate them to a data provider that provides good data and gives you good rewards. Or you can stake them on P-chain directly to the validator, where the tokens are locked for a bit longer, but the rewards are usually greater because you're securing a different part of the network. And all this allows you to firstly secure part of the network, to make sure that you're delegating your vote power, you're making the data provider that provides better data a bit more important, thus adding things to the system. But it also allows the whole network to function dynamically. When somebody is providing bad data, the delegations flow away from them. And as you do this, you also earn rewards. And another thing, if you have FLR tokens, you should wrap and delegate them to be eligible for FLR drops. So each month, as part of the how FLR drops are distributed through an airdrop, we're also adding some additional FLR drops to people that actively participate in the system. And as I said before, you should always monitor the performance of your validator, data provider, and make sure that they're on top of their game. Otherwise, go to somebody else and make sure that the network is correct. The easiest way to do it is to use FLR portal, when you can easily see who you are, what your balances are, who you're delegating to, and you can also claim delegation and FLR drop rewards. This account that I said just now for the purpose of demonstration doesn't have any pending rewards, but it is very easy to delegate. You just open up, select the data provider, which you can easily compare to how well they're performing here, what the reward rate is, and how well the data that they're providing looks. Get on it and start providing additional security to the network and making sure that the data we have on it is correct, on time, and not missing. So we now know why we need data. We know how we get it on FLR. We know what's happening with it and how you can secure it. And just again, so the oracles we use, the main thing is we're not adding data if there's any compromise on security. So all the data that gets added, both to the FTSO or the FDC, goes through the whole system of the stake, through the whole FLR system protocol. And every data point you have on chain, be it FDC, when there has to be a compromise, where there has to be a consensus of how specifically a Bitcoin transaction has been observed, or FTSO, when we take a weighted median on how exactly the final price should be calculated. All this is secured by the whole stake, not just the data providers, but also the participants in the ecosystem. And maybe just to provide some numbers, so currently more than 70% of FLR is delegated to various data providers. So there's around 100 of entities providing data. And all this is creating a strong incentive to provide strong data. And we've seen this throughout the history many times, that the data providers do make sure that the data they provide is good, and there's no compromise neither on security and neither on liveness. So as a dev developer, you also need to make sure that the data is always available and you can count on having some data there where you need it, not just saying, oh, well, price was that 10 weeks ago. Okay, let's shortly dive into each of the two protocols that provide data on FLR and see what exactly they do. They'll be explained in much more detail at a later point, but let's just see what's happening. So FTSO, the FLR time series oracle, is useful for probabilistic data. So prices, but not only prices, can be any data feed that kind of varies and can be closely approximated. Event attendance, weather data, how much rainfall a specific area had, what was the gas price at specific, what is the current gas price on specific chain where you're not exactly sure what the current block is, the gas price might change, and so on. We currently have exactly 38 feeds on Flare. On Canary network and on test network, we have much more feeds, and on Flare, an additional 12 feeds are coming in the next week. So we're enlarging the set of data feeds available on the network, and all these can easily be visualized in the Explorer. So again, the Flare Systems Explorer, the one that I spoke about, it where you can see entities, well, you can also observe what's happening with a specific price feed. So you can check a specific price feed and see what's happening on chain directly. So this is sourcing data directly from the chain, and you have two different things for FTSO. You have the anchor feeds that are refreshed every 90 seconds, and you have block latency feeds, which are updated to be fresh every block, which is between 1 and 2 seconds. So this is how you can observe what's happening. And we have also done some historical analysis. And if you remember when everybody was a billionaire because CoinMarketCap was providing bad data, well, even at that point, the data providers find out that there's some mistake with how the prices are calculated there and move to different data sources. Okay, let's jump a bit deeper to see what's happening. So FTSO, what we really want to do is the following. So we pose a question: what is the price of Bitcoin right now? And the thing is, it's kind of difficult to properly answer this question without being either A, more detailed, or depending on somebody else. So even if you take a look at two different exchanges, let's say Coinbase and Binance, you'll see that the price of Bitcoin might deviate by a few dollars, but we need a single price. So what the FTSO does, the FTSO is a decentralized system of determining a specific number. Could be a price, could be weather, could be event attendance. It's again guided by stake. So, and the scaling, the core idea of scaling is the following. So we ask all data providers in the system to provide an approximation what they think the Bitcoin price is. And then we don't take the average, because then somebody could massively impact the price of the final calculation, but we take a weighted median. So we take the thing that is the most in the middle provided by data providers, but we consider how much stake they have, and we also make sure that we cap the stake at some points to prevent big providers and so on. But we guide the search for the correct price by stake and arrive at the middle point on what they think that is. So this gives us so-called anchor price. This gives us every 90 seconds, we source the whole data provider set, ask them what the price is, and this gives us a price for Bitcoin. But since price every 90 seconds is a bit slow, there's too much lag to be very useful, specifically for high frequency things. We also want small increments in the middle. So what we do, apart from consensus on the whole thing, we also have these block latency prices. So the prices can be updated every block, which is between 1 and 2 seconds. And that time we randomly select a few data providers, again guided by the stake and guided by the private and public key pair, so they can submit small corrections to the prices. And in that way, we have a strong, resilient price every 90 seconds and small corrections to prices that are nicely following how price evolves through time. And this is how FTSO works. So we get a price that is available directly on chain, available on Flare for free. You can read it from any smart contract with just a simple 10-line function, with the whole contract being just a 10-line contract, and that's it. But in the background, behind the scenes, we do a lot of things to make sure that the stake that is considered when calculating these prices is exactly the stake that is also considered when calculating the blocks. And you know that the whole security assumption is always the same. So if you're trusting the blocks, you can also trust the data feeds. And specifically in the FTSO Explorer, you can, both in the FTSO Explorer and the Flare Systems Explorer, you can monitor this. We have some automatic monitoring set up to make sure that things are always working correctly. And this has been alive and accurate since 2021. So since September 2021. So for more than 3 years. And we've been through quite a lot. So there's been a few USDT, USDC pegs in the middle. Some exchanges went out. CoinMarketCap had problems. And throughout all this time, the FTSO system has proved to be resilient. So we never submit, the FTSO system at the end never reported the bad price. Even if a few data providers reported bad price, the rest of the stake pulled the price to the correct level. Even if the exchange was out, the data providers quickly figured that because an exchange was submitting a bogus price and their price was way off from the correct price, the rewarding was broken. So the data providers immediately switched to a more secure and resilient exchanges and removed the outliers. Even when the pegs were happening, the data providers recalculated the price not according to USDT, how most of the coins are usually trading, but according to USD, as to make sure that they're submitting the correct price. And we can safely say that the FTSO system has proved to be resilient enough, even in the cases of those outages. And why is that important? Well, think of security as an insurance. You don't need it until you need it. And being sure that even when there's something bad happening, even when you have problems somewhere else, that your chain will still function and all the links in your chain will still hold, all their security assumptions won't break, is very important because the depth is tested when the things are tough. Most of the protocols get hacked when something bad happens, either with oracles, there's something happening in the market, but in that case, we make sure the whole system makes sure that the thing is resilient. Okay, and the other thing is FDC, or the FLR data connector. And as I said before, the FLR data connector allows us to pose deterministic yes-no answers. Well, and we don't just want to stay with the yes-no answers. So the data connector allows you to get answers to deterministic yes-no answers. And when the answer is yes, you also get some additional metadata that's enriched depending on how you want to enrich it. And specifically, the first iteration had enriched data from other blockchains. We currently supported Bitcoin, Dogecoin, XRP Ledger, and EVM events on Ethereum and any layer 2 that is EVM compatible. What that means? Well, that means that an application, a tab, can issue a request. Did this Bitcoin transaction have resulting response? It did. And here's an additional information. Here are the inputs that were present in the application, in the transaction. Here are the outputs. Here's what has happened with them. Here's the block it was included in. Here's the timestamp and so on. And with this, you have a secure data. You're sure that this has happened on chain when you can then do something on top of it. And specifically with the addition of EVM events, which are also already supported, you can ask much more. You can ask, did this Ethereum transaction happen? And did it emit such an event? And again, you get back a response. Yes, it did. This was the initiating address. This was the target address. This was the call data. And these 10 events were emitted with these signatures. And this is the data. And then you can decode those events. And since you are on smart chain, when you can do computations, when you can calculate pretty much anything you want, where you can modify state, you can say, okay, did somebody NFT make a Uniswap swap that passed through these few ticks? Did somebody created a nice arbitrage opportunity on another chain? You can use FDC, pull this data to FLR, and then act upon it on FLR. And because we're connecting multiple chains via a single hub, you can easily integrate your dApp to pass through FLR, but do something meaningful on multiple chains. And importantly, we're not only supporting EVM chains, we're supporting also the chains without any smart contracts. What that means is, that means that you can add additional computational abilities to a chain that otherwise doesn't have them. And again, in FLR ethos, at its heart of the FDC, we have the security. And we'll explain this here. So where's the security part of the FDC? Well, firstly, you create a data request. So this is a bit different than FTSO. With FTSO, you're constantly getting a data kind of in a stream fashion. With FDC, you have to request a specific data point when you need it and in whichever form you need it. You request a data, and then attestation providers, which are data providers just under a different name, check the answer to this yes/no question. They arrive to a consensus. They say, okay, yes, we're all seeing, or the majority of the stake is seeing that this Bitcoin transaction has happened. We're gonna approve it. We're gonna say yes, it did happen. We're gonna enrich it with this data, and then add this, and then finally finalize this to an FDC. So you request the data, the whole network, the whole stake on the flare, even this fine flare that somebody else might be delegating to a good performing data provider, comes to a consensus, say, yep, this transaction has indeed happened. And at that point, you can reuse this transaction, you can use the information about this transaction on Flare. Okay. And importantly, since we are now on FDC, what else can the FDC power? I was just informed there's some connectivity problems. Okay, so you can also use it to gather some external data. So you can gather weather data, you can gather moisture data, you can gather reports on what the precipitation was. And in that case, you can then settle this directly on Flare. And what does FDC already power? So we had a very nice example of decentralized Olympic Games prediction market when we pose a specific, very simple and very detailed yes/no question. So there was a football match or a basketball match between South Sudan and Puerto Rico, and there were a few APIs that were reporting this data. And the question that went to all the data providers, to all the attestation providers was, did indeed South Sudan win this match at that specific point? And we could easily get back yes, no answer, what was the result, the timings, and maybe some metadata. Okay, this did happen, there was a strange decision made by the referee, and so on. But what it allowed us to power a full decentralized Olympic Games prediction market when you can make a bet, and the resulting outcome of this bet would not be decided by somebody clicking a button or by somebody saying, yes, this did happen, but the resulting match, the resulting result would be settled by the whole network observing a predefined, a predetermined, deterministic thing. Okay, that's what we're going to consider a win, and that's what we're going to settle upon. This was a very nice example that is currently not running because the Olympics are not on anymore, but it was a nice example of how Web2 data can be integrated with blockchain and made sure that always work, and made sure that each of the steps you take in both making a prediction, acting upon this prediction, and executing it, you don't have to trust anyone. All these links in these steps are always verified by the whole stake, by the whole network. And the third thing that is nicely powered, and you've probably already heard about it, are F assets. So F assets are over collateralized synthetic tokens. When you can take a non-smart contract network, you can use FTSO to properly price collateral and token, and you can use FDC to observe what's happening on the other side to make sure that you can use a non-smart token on a smart chain while always being sure that the redemption process will work. So again, the whole chain of things that you need to ensure that you're getting your value back at the end is secured by the whole stake. So we're making sure that this chain of security where things can go wrong is pretty much made rock solid. Okay, that's most of the content we had for today. So I see there's already some questions popping up. So if you want to meet us, we're going to Encode London Hackathon in just a week. So if you're there, come say hi, come build with this amazing FDC and FTSO so you can gather external data, you can gather pricing data, and you can build something really amazing. And remember, gathering external data doesn't mean that you have to gather just the data. You can do external processing. You can do a bunch of things on external computers supported by a network of validators, and then just use the EVM to execute on top of this. We're going to be at DEF CON in Thailand, but we're also going to be at Hackathon. So if you're there, drop by, say hello, and we can speak about what can happen on this network even more. Or you can ask your local blockchain group or join our Discord, tag us on Twitter, and we'll see, and we can find something to work with. Okay, and just a few other things. So I've mostly talked about what's happening on Flare, so what we have enshrined. But a lot of things are already built. A lot of stuff is happening, and we have a really growing and bustling DeFi ecosystem. So here's just a list of some selected things that we have. So we have a liquid staking, we have some swaps, pools, farming, perpetual futures, all powered by the FTSO. We have a native stablecoin, we have treasury bonds, borrowing and yielding, and we have a really nice intent-like on-chain order book when you can have this centralized exchange functionality that is powered by intent, but always secure in the back by the FTSO system when you know that the price is never deviating that much. So this is all just for a final thing. So we're going heavily into bootstrapping DeFi on Flare. You've probably heard about these reward Flare incentives. When if you participate in the DeFi ecosystem and the qualifying dApps that agree with this Flare ethos, so they're audited, they have verified contracts, and they make sure that everything is working correctly. And we've checked that they use Flare's core protocols. You can be additionally incentivized by the Flare incentivization committee and then by the dApps, however they distribute this, and earn additional yield by just participating in the DeFi ecosystem and being there and seeing what's happening. Okay, that's mostly it. So if you want to learn more, check the Dev Hub when you have the examples on how to build on FTSO, how to build with FTC, what else can you do, how to deploy smart contracts, and how to work with Flare. Join us on Twitter, and any additional questions, there's always Discord when we hold regular office hours when you can check what's happening. And the Q&A session. So I think John has prepared some questions for me. And the first question is, does Flare have a private state like Aleo or Aztec? And the answer is no, it doesn't. So currently, everything that's happening on Flare is fully public. So we don't have any private state. All the settlement, all the transactions, everything is fully public. You can, of course, use cryptographic primitives if you want to hide something. So specifically, both FTSO and FDC use commit reveal scheme to make sure that there is no copying happening. And most of the attestation proofs in the FDC are hidden until you reveal them. But there's nothing like full private state when you would be able to hide coins, or you would be able to hide balances or so on. So there's nothing like this. The second question is, how does Flare ensure security and decentralization while maintaining scalability? Well, it's quite a lot of work. So maybe I can't really fully answer the question because we have like only 10 minutes left. But the thing is that we're working really hard with data providers to make sure that the tooling they use is decentralized, so that they're not relying on a single client. There is also a very strong FTSO management group, which makes sure that any colluding data providers are um, firstly frozen for a while and then can be permanently executed. So we don't have these people just cloning data providers. But this scalability problem is pretty much solved by making sure that the nodes are correct and that we make our protocols as lightweight as possible. So we are making sure that the addition of new protocols on network, so additional new pluggable protocols in network, are not that problematic and not that heavy. So, and it's a constant battle between wanting to have everything and being able to put things there in a concise way to still have them optimized. Uh, the next question is, what are some real world use cases or applications already being built on Flare? So I think I can just scroll back a bit. So this DeFi ecosystem is quite big. There's also a nice, I also like this Olympic Games prediction market. There are some new coming up. We have a almost stable coin coming up that is again secured by the FTSO and FDC, and so on. So there's we're focusing quite a lot of DeFi, but with FDC we're trying to attract Web2 things, specifically, from gathering additional data and seeing what computations that can be done off chain, specifically some AI inference, how this can be leveraged directly on chain. How does Flare differentiate itself from other blockchain networks, especially in terms of interoperability? Um, so the main differentiation is in this: the enshrined oracles directly on chain. So consensus, the proof of stake, the EVM. This is where we try to be as similar to other chains as possible to make tooling easier, to make transitioning easier, to make developer experience as simple as possible. The main differentiation comes from this, that we have this FDC that allows you to query state on different blockchains, and with Relay, we also have the ability to relay this data forward, and that's most. We're working quite a lot with them to make sure that there is additional interoperability. But the main differentiation is this, that we try to be interoperable with blockchains and Web2 data, but we never compromise on security. So things can move a bit slower, but we don't want yet another multi-sig that is controlled by a single entity. What role do Flare's native assets, FLR and SGB, play in the ecosystem? So pretty much as I'd mentioned before. So FLR is the native token for Flare network. You need to use it to pay gas fees, although we support account abstraction, so you can use other tokens, but mainly the core principle of FLR is to firstly pay gas fees, and secondly, it is used as a stake to secure the whole network. So if you want to add some weight to your data provider, if you want to add some weight to a validator, this is where Flare comes in action. So it's a native token. Pay for gas and stake it. And similarly, SGB for Songbird. So the main use of SGB is, again, delegating to a data provider so they get more weight, and you know that they're adding their vote power to the correct data sources and paying for gas fees. And I think we have some time for the final one. Who will be on the Flare run in Bangkok? There's going to be quite a big team in Bangkok, but Kristaps is the main guy behind the Flare run in Bangkok. So I think he'll be there for sure. He'll be running. I think some of the team will also show up for breakfast, and maybe one or two will be running. But Kristaps, our DevRel, will be the guy who'll be trailing with you. Okay, so that kind of concludes the official part, and now the alpha I told you at the end. So if you take a peek at this QR code, if you scan it, and if you go through the quiz, um, which you should know the answers because I pretty much went through all of them in my presentation. If you go to the end and join our Discord, you might be eligible to win a full set of FLR merch. So a t-shirt, a cap, a water bottle, and an amazing pink hoodie. So I suggest you try really hard and get the answers correct. So I'm gonna leave this on for a bit, but yeah, thank you again for joining. I hope this was educational, and I hope I'll see you again next month when we're gonna explore a bit more on how to start developing on FLR. So what this EVM compatibility means, and how you can deploy your own smart contracts on FLR with very few clicks and make sure that they query the blockchain, see what's happening, and see what's going around. Thank you. Don't forget, take a picture. If the stream ends, take a picture so you can still scan the QR code later. And yeah, the merch is amazing. So if you ever come to our booth somewhere, try to get some of it. Okay, thank you, and I'll leave this on for a few minutes so you can finish. And see you.